Hi, this is Victor and welcome back to my math tutoring channel. In this video, we will solve that integral, which is sine to the power of 6 of x plus cosine to the power of 6x divided by sine to the power of 2x cosine to the power of 2x dx. And the technique that I will be using is a3 plus b3, which is equal to a plus b times a square minus ab plus b square. And I will be using trigonometric identity formula and trigonometric integral formulas. Now, whenever you have any trigonometric function that it has a power more than 2, because all the trigonometric identity formulas are either to the power of 1 or to the power of 2. And in this example in front of me, I have sine to the power of 6x plus cosine to the power 6x. So I have to make it to the power of 2. So let's rewrite it. So my integral become sine to the power 2x and all that to the power of 3 plus cosine to the power 2x, all that to the power of 3, divided by sine to the power of 2x cosine to the power 2x dx. Again, sine to the power of 2 to the power of 3 is sine to the power 6 of x and cosine to the power of 6 of x. And I thought that way because all my trigonometric identity, it's either to the power of 2 or to the power of 1. So in that case, you have to choose either to the power of 1 or to the power of 2, but like in that case, it's obvious that you need to choose to the power of 2. So now my numerator look like a to the power of 3 plus b to the power of 3, which is equal to that formula here, a plus b times a square minus ab plus b square. So I'm gonna rewrite my denominator as, and in that case, I have a is equal sine square of x, and my b is equal cosine square of x. Okay, so it's a plus b, which is, it will become sine square of x plus cosine square of x times a square, which is sine to the power of 4 of x, because sine to the power of 2 square is sine to the power of 4 of x, minus a times b, which is sine to the power of 2x cosine to the power 2x, plus b square plus cosine to the power 4 of x, divided by sine square x cosine square x, and all that multiplied by dx. Okay? But I know there is trigonometric identity formula that said sine square of x plus cosine square of x is equal to 1. So my integral become integral of 1 times sine to the power 4 of x minus sine to the power 2x cosine to the power 2x plus cosine to the power 4x dx divided by sine square of x cosine square of x. Now I will distribute my denominator on every integral. Oops. Sorry for that. I will distribute my denominator on every numerator. You'll see what I mean. 1 multiplied by anything is the anything, so because 1 is the neutral element of multiplication. So my integral becomes sine to the power of 4x divided by sine square of x cosine square of x minus sine square of x cosine square of x divided by sine square of x cosine square of x dx, and there is a dx here, plus integral of cosine to the power 4 of x divided by sine square of x cosine square of x dx. Because of that minus and that plus, I can split my integral into many integral, and then I have the common denominator. I can split my denominator on every element of my numerator. Now, if I look at my first integral, sine to the power 4 of x, this is not sine 4 of x, this is sine to the power 4 of x here, divided by sine to the power 2 of x is integral of sine to the power 2 of x divided by cosine to the power 2 of x dx minus integral, here I have multiplication divided by multiplication, I don't have plus or minus, I can simplify it, become minus dx, plus, and here cosine square, and that 4 become 2, cosine square of x divided by cosine square of x divided by sine square of x dx. I know that the integral of sine square of x divided by cosine square of x is tan square of x, because sine divided by cosine is tan, so it's integral of tan square of x dx minus integral of dx plus integral cosine divided by sine is cotangent square of x dx. Now there is a trigonometric identity formula that said tan square of x is equal sec square of x minus 1. So I will replace this by integral of sec square of x minus 1, all that dx, minus integral of dx plus, and integral of cotangent square of x is cosec. I can replace cotangent square of x by cosec square of x minus 1 dx. We're almost there, and now because of the minus I can split it into two integral. It becomes integral of sec square of x minus integral of dx minus integral of dx plus integral of cosec square of x dx minus, there is a dx here, integral of dx, because the minus 1 times dx is integral of dx. And now I will apply the formula of integral sec square of x. There is a formula that said it's tan. You don't have to prove it. It's a trigonometric formula. Just use it. So the first integral, it becomes tan of x minus integral of dx is x minus integral of dx is x, and integral of cosec square of x dx, it's a formula again. It is equal to minus cotangent of x, and minus integral of dx is x. So, and plus c. So my answer will become tan of x minus cotangent of x minus 3x plus c, because minus x minus x minus x is minus 3x. If you like my video, please subscribe to my channel. That would help me tremendously. And if you push the like button, I would really appreciate it. Thank you for listening.